So the speaker for today has cloud security finally come of age. Stephen Porter from Trend Mirco. Steve, thank you very much.
With such a small group, we can make it interactive as well, so we can pick up questions as we go through. So we met at a VMware event where I was presenting, and we thought this session might be of interest to a broader audience. Am I going to mess things up if I stand up?
No, not at all. You're in.
Just this. So I've picked up what I think some important things. Where do you want?
That's fine. Yeah, you can move around.
So probably the place to start is what people's perception is about where security lies. And for many people who have a traditional data center, they're thinking about virtualization. And the great thing about that environment is they have complete control, because they're managing everything. They're managing the servers, they're managing the software stack, they're managing the processes, the ISO 27001. But sometimes when they get lured into the attractive kind of cloud proposition, they forget that some of those controls disappear. So what we've seen when we've been talking to our customers and to some of our partners is that there's a gap that's starting to emerge between the control that people actually have and where the responsibility lies. So when you start looking at public cloud or private cloud, some of those processes and controls that they assume are there aren't actually there. To try and put that into context, I don't know whether you've ever read a EULA. Most people's perception when it comes up and says, have you read the conditions box, we all just tick yes, unless we're particularly paranoid. But if you look at it, what it's saying is they will guarantee that the server will work and that there will be a ping and power, but anything to do with the data, which is the crown jewels from your perspective, is your responsibility. But in putting stuff into Google or into Rackspace or into Fujitsu or into anywhere, we all assume that because it's a data center, we have data center class security, which we do from a network perspective and also from a physical perspective. Class 5 data center is a pretty secure environment. But the data that's in there, that's your crown jewel, so credit card information, patient information, if it's in a virtual machine or in a physical server that's inside that data center environment, then it's open to risk. So what we've seen when we've been talking to customers is this gap is getting bigger. And there's a number of things that we need to address. One is kind of the responsibility and the understanding of where the responsibility lies, and understanding that there is a gap. The second part is putting in place processes, tools and education that say, well actually, in order for us to bridge that gap, we need to take some certain actions.
Can I say, one of the reasons why I and most other people just tick that end user license agreement box is because if they were to read it, it wouldn't make any sense. Very dense, very difficult to read. And I think it's an opportunity for somebody within the community to write maybe a plugin or some product which deals with that and simplifies it so you can understand what you're signing up to.
Yeah. Do you want to make a comment about, because we're doing something very similar about privacy statements?
Yeah. Currently I'm developing an application that will scan through privacy policy. It's very difficult to read and very boring also. So the application is going to scan through and give you, I have a list of items it's going to check. It's going to check how the website is going to secure your information, how it is going to collect your information, who is going to process your information, who the data controller is, and for those countries around the EEA, if it's going to transfer your information outside EEA. And I think that can also be applied to this with effective standards.
So some hope. Okay, thank you.
In some respects. we had a lady from the European Union come and present to one of our customer events recently, and she was talking about the Data Protection Act and how it's going to evolve. And in a security context, she said one of the challenges they have to get over is the use of data. So in the particular example she quoted is that a spammer sending information in, if we want to stop it, we have to notify them that we want to stop their spam coming in, because it's their data. So there are some loops that still have to be resolved.
It's fascinating. If you didn't, what you'd be up for?
You'd be up for breaking the data protection rules. So the topics I kind of wanted to cover during this session really were kind of around the network and the user access, how we can protect the machines that actually run the workloads, and then to start thinking about the data and the way that we protect the data. If we're going to really embrace cloud technologies and to use cloud or virtualization in the way that most people kind of portray it, it's got to be very portable. Because the whole idea with cloud is that it's dynamic, that you can go in and come out almost at will, and that things will grow and shrink as you demand or the workload demands. But in order to do that, a number of things have to be in place.
Do you think the law side of things is catching up with that?
No.
Hence my question. Because there's been a couple of cases, I don't think in the UK, but certainly out in the US, where the feds have gone in and taken out the hardware and have killed companies because it was nothing to do with them, but their data or their systems just so happened to be sat on the same hardware as the bad guys, and so it got...
There's a pretty interesting thing going around at the moment with Microsoft. So if you take Office 365, which is a cloud-based service, it will run in one of the Microsoft-based data centers, whilst they will try and make sure it's in a UK data center, so either be in Dublin or in Copenhagen. In the event of a disaster and the triangulation, it will go to the US. As soon as it goes to the US, it falls under the Patriot Act, which says the US government can go in and look at your data. So, there are a ton of legal challenges around that. So, I think it's a minefield in one respect, but the attractiveness of cloud-type services is kind of luring people into it, perhaps with a false sense of security and a false kind of reassurance about what they can expect out the back end. So one of the first things we have to start considering is the network and the perimeter, because for most people who have IT in their own environment, it's a fairly controlled environment. Everybody on the inside is safe. All employees work inside the corporate network, and so therefore anything on the out is bad and everything on the in is good. Apart from the fact that we're going round punching holes in it. So, we were talking earlier on about empowered employees. Making productivity work with flexible working means that you can work from Starbucks, from a hot desk, or from a customer. In order to do that, you have a connection back into the data center, which is fine if it's your data center, but if we're talking about cloud-based services, an application that might sit on a laptop, whilst it might come through your network, will ultimately go out to Salesforce or out to some other service provider. So what you have is mixed network environments, and this term of reperimetization is kind of the one that's in vogue at the moment, where the perimeter is coming in. So for a corporate environment, it's going to surround the data center, and everything outside of that is kind of open, because you're going to be using wireless, or you're going to be using public network environments. But you're also starting to see bridging between the corporate environment and other environments. So in this context, it might be your network connecting into a cloud provider's network. But if you've outsourced a service, so if you've outsourced your call center or your order processing or your supply chain, what you're doing is you're bridging multiple networks, which might include a cloud provider. So your supply chain vendor may have actually outsourced to buy in a SaaS application from a cloud provider. So you've got these multiple connections between different parts of the network. So you have to start thinking about how you can apply security to that reperimeterized environment and deliver the kind of security that will protect your crown jewels. Kind of makes sense?
Does that mean that attempts to make security data-centric are out of vogue?
No, data-centric security is kind of where most people are going these days. So whilst the perimeter is still important, it's not the be-all and end-all. And it's still important to have a perimeter. So the idea is that, and it's particularly relevant in a cloud provider's environment because it is going to be multi-tenanted. So whilst you still need a perimeter to keep the bulk of the bad stuff out, what you need is multiple layers, because if you're in a cloud provider environment, then you need a layer that represents either a client or a particular workload. So most of the analysts these days talk about multi-tiered security, with very generic stuff on the edge to keep the obvious things out, and then as you get closer and closer to the workload, it becomes more and more specific to the customer and to the workload that it's trying to protect. The other thing, and it kind of links back into some of the comments that we were talking about earlier on, is that the bad guys are becoming more sophisticated. So, a lot of the things that you see in the press now and you see in the trade magazines and things are about compromises that have happened to organisations where data's been lost or reputation has been lost. But unlike the old days where it used to be a traditional virus attack or a piece of malware, which by its very nature was about volume. It was spamming email, or it was attacking all the IP addresses, or it was attacking ports in the network. These days they've kind of switched from mass threats to more targeted threats. So most of the time when you see a breach has taken place, it will be a targeted or an advanced persistent threat. Is this a term that you're hearing fairly often?
I remember just before the Olympics was announced, they were saying that they're very opportunistic, these attacks as well. Because there's something happening in the newspaper, in the headlines, then the spammers will target that. The most recent example, I guess, was the NatWest Bank. So a lot of spammers try to get details from NatWest employees by sending them false emails. Opportunistic, very specialised.
And that's really what we've tried to pick up on the right-hand side here, is that a lot of the targeted attacks start with either fairly obvious information or information that's readily available. So, the source of information these days for most people, or for most of the bad guys, are the things that we've all been talking about: LinkedIn, PayPal, Facebook. And the problem is, the security professional, so us as individuals, you said it earlier on, you're more paranoid about things. But the end users that we're supporting are less paranoid. They're used to IT that just works. And so their reaction when they get a Facebook request from a friend is to accept the request. If you got a LinkedIn request from somebody that worked for an organisation that you are working with, again, you'd assume, perhaps falsely, that that person is working in some way with you and your organisation. So what we've seen is these spear phishing, the drive-by downloads are the way that people are starting to get in. A good example of that is if you look at the detail around the RSA compromise. It was a spear phishing attack. Have any of you read the detail?
It was a very simplistic attack, though, wasn't it?
Yeah.
Same as like the LinkedIn account, the LinkedIn one where all the passwords were taken. It was a very simplistic attack. Very targeted, but very simplistic attack at the same time.
The beauty of the RSA one was that the guy received the mail and the email system said it's junk, put it into the junk box. And because he thought it was relevant, he actually went into his junk box, pulled it out, and then clicked on the URL. So, you know, it was a very clever attack because he thought it was from a friendly source. The other thing that we're seeing is, rather than direct attacks, is attacks via somebody else. So there was a very famous Boeing example. You know, Boeing being a security organisation is pretty paranoid about security. But they'd outsourced their cleaning. The cleaning company that does office cleaning is not really that paranoid about security. So unless you apply your security policies that adhere to your organisation, to your partners, then they are going to be the weak link. So we've seen these kind of highly visible attacks are often now coming from targeted, specific attacks, and it's the simple things that break down. The other thing that's happening is that they're becoming more sophisticated. So whilst, once they're on that PC or on that particular device, but what they start doing is navigating inside the organisation. And the bad guys are quite clever. They know the kind of timing rules that different tools work on. So at InfoSec recently I was talking to an organisation and they'd been attacked. But it wasn't an obvious attack where they kept trying to attack the user ID and password every 30 seconds. They worked out that if they left it 8 minutes, that it wouldn't get picked up, because the log entries were being checked every 5 minutes. So if they only did it every 8 minutes, that they would have more chances of attacking that particular server. So, people are becoming very clever in understanding what the tools are doing to try and protect them, but also in trying to get connected and get something into the network environment. So in the cloud context, we've got to think about almost assuming that the environment will be compromised, and therefore we need to be able to protect and identify things that are happening inside the network and almost provide reassurance to the customers that are going to buy your cloud services that you have tools in place to actually check the network environment and not just assume that I've thrown up a brick wall and therefore it's going to be secure. So in this environment what we have is somebody breaking in, getting onto a particular PC and then coming back and creating a command and control server. So the other thing about threats these days is that they don't just come from one particular IP address or from a particular spammer. They evolve and they change very regularly. So we've seen in some of the attacks that we've been involved in where they create a command and control server and then you end up with botnets all inside the network. So you need to look for kind of activities that are not completely obvious. So the kind of things that people are starting to develop, and there's a number of different vendors that are coming out with it, are solutions that are looking for different things. So they're not only looking for the obvious things, is this a bad URL, is this a piece of malware that's attached to an email, but they're starting to become much more sophisticated and look at communication that's happening that's unusual. So we had a customer stand up at one of our customer events and he was talking about a server that he'd had inside his network that wasn't under management. So what had happened was it was part of a development project. The development exercise happened and then the bulk of the servers got moved into the data center and therefore became managed and secured. But one of them was left under the desk. And it became vulnerable because it wasn't being patched. It became vulnerable because nobody knew it was there. And so what happened was that it got compromised and it ended up being a command and control server, but it was calling out. Most people with a security head are thinking about things breaking in and not things calling out. So you need to start looking at things from different angles and different perspectives. So we've got to think about communications that's happening inside the network. Is it normal for this particular user ID, which might be a call center person, to be logging on to a database server? it's very unusual activity. So you need to kind of look for the unusual activity, but also start learning from it and building rules that say this is what constitutes unusual activity. And then the attack behaviour is kind of changing quite dramatically as well. So from simple malware, we're now looking at things that are scanning for IP addresses or looking for open ports and things like that. So the network is one of those areas which a lot of people think is very secure because they put appliances and things out there. But in a cloud context, where it starts to be used in a multi-tenanted way, then it opens up other vulnerabilities.
Aren't we risking the same model of the malware, the antivirus that goes looking for 500,000 bits of software which we don't want, rather than looking for the 40 pieces of software that we do?
Yeah.
Is there? I mean, maybe the answer is you just have to do both. But is this the opportunity to start building the white lists of the acceptable behaviour and basically acceptable behaviours?
Yeah, and that's exactly the process that we as a vendor and a number of others are going through is trying to build intelligence in. So one of the things that we've seen with antivirus and pattern files is that if you identify each one individually, you end up with a pattern file that's almost bigger than the workload it's trying to protect. So we've kind of flipped round from looking for individual attacks to looking for types or classes of attack with similar characteristics. Because in the old days you'd be identifying a spammer or an IP address that's bad, but because they're evolving all the time, if you carried on doing that, you'd have an ever-growing list, whereas if you look for a type of attack that might use multiple different IP addresses or multiple different spam aliases, then you can pick up the class of an attack rather than all the individuals, and then you get into whitelisting and blacklisting, which optimises the
But what you're proposing is a never-ending task, because it just gets more and more complex, and you will never be able to examine every possible unusual behaviour. Otherwise, if you did that, you just slow down everything.
Slow down the network.
So, I mean, that sounds to me like a catch-up game. Maybe the solution is to restrict security, restrict flexibility, restrict capability, and develop something that is becoming interesting to researchers, which is called provable security. That is, say, you outline what your threats are, and you have countermeasures for each of them, and you so restrict your activity so that you can contain it. So you actually restrict capability, you restrict flexibility, you restrict a lot of things. It's bad news for the users, but the good news is that you could develop some strategies for sensible computing.
But that would
Not exactly a business enabler, though.
Well, it depends what your business enabler is. If you have reputation damage because you're so flexible, then that is definitely not a business enabler.
Well, I can see the point in trying to detect this activity once something's been compromised, but in the example you quoted about that server that was just under a desk somewhere, isn't that a failure of process?
Yes.
That should be addressed.
Yeah.
But and shouldn't we be looking for the vulnerabilities so things don't get compromised in the first place?
But that approach of looking for unusual behaviour wouldn't have stopped the flame virus, which used a certificate that got through, because that would have been regarded as a valid certificate.
Yeah.
So there are limits to that approach, and it's a catch-up game.
Well, I'm sorry to interrupt, but the thing that we come up against with our clients is a focus on technology, and I know you're from a technology company, and technology is important, but they think, right, we've got our firewalls, we've got our antivirus, we've got our IPS system, we're safe.
Yeah.
Well, you haven't looked at your processes, you haven't done security awareness, you haven't looked at risk management.
And that's exactly what we were talking about earlier on. So we just ran an enterprise customer event where we were talking about exactly those things, and what came out very strongly in the panels is that it is a collection of those three. It's a collection of technology which can help. Process is equally important, but probably the most important thing is education. Because the people that you've got that are kind of mature have kind of forgotten that they need to be concerned about security because they've kind of just always been in that environment. The youngsters coming in, the Generation X or whatever you want to call them these days, they're so used to technology and the kind of dynamic nature of it that they assume it's always going to be safe. And so therefore you need to educate both ends of the spectrum. One to become much more security aware because they've become lax, and the other because they've never thought about security and therefore they need to be introduced to security.
Well, I work for a multinational organisation who shall remain nameless. We all trooped over to Amsterdam for a meeting. They had a big room full of 100 people, half of which were security people and half of which were developers and project managers, etc. And we had to go around the room and introduce ourselves and tell everybody how much of our time we spent on security. So it came to me, I said, well, 100%, because I'm a security person. Came to the guy next to me, he was a developer, and he said, I spend 0% of my time on security, and all the security people just went...
Well, actually, I would say it could be very good that you spend 0%. If security is so built into a product, I'm not saying it will be, of course it won't be, but really security should be 0%. We should be looking at security now in the same way they looked back at quality. Okay, as an ISO 9001 quality manager in several previous lives, I know the damage that can do if it's taken up badly. But it does go back to the Crosby adage that quality is free. So is security. It
should be a taken that these guys produce secure code, but we're a very, very long way from there.
If it doesn't, the product is actually broken.
Oh yeah.
But it takes...
I agree with you. I totally agree with you. But that is not the reality of what's out there.
Writing secure code is the same as trying to get 9 women to give birth to 1 baby in a month. It's a very long process and a very difficult process. There is no easy shortcut. And in these days, things change so quickly that writing secure code sometimes becomes an uncommercial luxury. And I think that's the problem. My real point, and the point I didn't really explain too well in my last interjection, was I think the mindset is going to be trying to restrict people to what they can do in organisations, because that's the only chance you have of getting control. Because if you let people do everything, if you let them bring their own device in, if you let them use whatever particular piece of free software they've found on the web, you're just creating minefields for yourself.
No, I think the point you make is very, very valid indeed. The problem is not everybody could work to that environment. For example, these students in universities, in academia, exactly the opposite. A very open environment is what goes, and they just wouldn't tolerate. In fact, they'd probably cease to function if we did have that kind of restriction.
But the universities don't count for anything anyway. They don't produce anything. So it's not really relevant for them. And I agree, having an open policy would be okay for them.
Most people have kind of settled on a halfway house. Yeah. And the old days of the security or the chief security officer being the yes-no guy are no longer suitable, because if he says no all the time, all that happens is that the business goes off and does something else.
And just ignores it.
Yeah.
But that's what they said about quality control. Yet people's car builders' reputations now make a great play at the fact that they've got great quality control. So it is an attribute, not a disadvantage.
I think it's more about risk management. It's understanding what the risks are and enabling the business to make an informed decision about risk.
And educating the users as to why you don't want them to do that, so that they don't subvert it then. Because if you stop somebody from doing something and don't explain why you can't do it, they'll just go around it. And so if you explain to them and educate them that that's why you don't want them to go around it, because this is all a bad thing, hopefully 90% of them will say, okay, well then we won't do it, because I now understand why.
If you can get people to the point where they see something they think might be a bit iffy, and they pick the phone up.
That's the idea. That's the education piece, and the awareness. The obvious example that we use all the time at the moment is around BYOD and the different ecosystems around different devices. So BlackBerry was very locked down and therefore became a corporate standard. But people have kind of evolved from BlackBerry now to Apple and Android. Apple's fairly kind of locked down, but the Android marketplace is open to anybody. So I can go up there, create a rip-off of Angry Birds using some super slick development tool with absolutely no consideration for security whatsoever. But if it gets on the marketplace, I can make several £1,000s very quickly just by it being there and being cheaper than the real Angry Birds. But there could be vulnerabilities, built within that environment straight away. So, the education piece is, I think, the important thing to kind of take out of that.
It's also, you were saying about reputational loss. I had a client who was trying to put a cost. We were trying to put a bid forward for a very expensive security installation. And he was trying to get past his board, and he kept coming up against this. But what will it cost us if we don't put it in? And it was practically impossible to put a cost against their reputation. And, he didn't get it through his board. The
mistake is treating securities like a capital acquisition, because a capital acquisition has a demand for return on investment, which most accountants in organisations rely on. But you can't sell the security as that, because it isn't a capital acquisition that has a return on investment, because if you try and put the numbers to that, it's very difficult. It's a cost of running a user, basically. So security necessarily has to be an overhead, and the issue is how much overhead you're prepared to give to your users. And that is where it should be positioned in the ledgers, not as a capital acquisition.
The other thing that we try and do is to flip it around and use security as an enabler. So if you are using BYOD or you are using flexible working, that if you have the security model right and it enables those capabilities, then there's a lot of gains to be had from that.
And it enables the business to understand what the risk is and let them take a calculated business risk to exploit opportunities.
So we had one of the guys
confidence to do that.
Yeah, we had one of the guys from the Jericho Forum present at this customer event, and he talked about exactly that. They don't have huge amounts of budget, so they have to decide which project is the one that gives them the best return on investment.
It's interesting now, all the recently highly publicised security incidents made it into the press. The cost of not having security would be fairly easy to estimate now, certainly now compared to 10 years ago.
I mean, the obvious one at the moment is RBS. Because, they went through an environment where the IT was compromised. And every other vendor that was out there suddenly came up with a campaign that said, switch to us. We'll give you £100 to switch. And kind of in small print, we're exactly the same as RBS, we're just as vulnerable. So to kind of come back to the network piece, there's a number of elements that we need to bring into play. One is getting access to the information and being able to analyse it. Part of that is identifying the obvious malicious content. So there are reputation databases out there that most of the security vendors have. So the solution can plug into that and pick up the obvious malicious content. Where a lot of things are going now are looking at sandboxing. So if we think it's a threat and we're not sure, then we want an ability to be able to test it and create a sandbox. We can run that program or to run the content through. So these seem to be the kind of technologies that are coming out now, looking for behavioural changes or things that are either obviously not supposed to happen or we want to pick up. But the more important thing is being able to create actionable intelligence. So being able to react to things that we found and take the appropriate action. So part of that is identifying where things are happening in the world. Most of the bad guys are not in Europe, they're in other places. So what we need to be able to do is to gather information about where threats are starting to originate from and what impact that might have on a particular network environment.
You need to hang out in some questionable forums.
Yeah.
And some of the non-Europe-based bad guys will be using machines which are based in Europe.
Yeah. And that's one of the things that comes out time and time again, is the network of resources that the bad guys are using are everywhere. So, from a network perspective, we need to go through these stages of catching the obvious things, identifying the less obvious things, but then being able to react to them and take some positive action, either just knowing that they exist and we need to lock down the network or to patch appropriately, or to identify things that we need to protect more securely. Our databases, our DNS servers, our AD servers, those kind of things, because we want to kind of lock those down more successfully. So, from a network perspective, if we're a cloud provider, we want to provide a reputation service that says, we believe that we will be compromised at some point, and we've taken steps to address that and to try and identify unusual behaviour. Because if you get into a multi-tenanted environment, which a cloud is, then it's going to be made up of a number of different network elements, and therefore we need to start thinking about things that can traverse networks or things that can happen. The other thing that we then start to kind of looking into is creating a security policy that we can apply across different platforms. Virtualization is going to be very strong in many cloud providers, but just as equally, physical servers could exist to support particular workloads. So if you're running a software as a service application, which is a cloud-based application, but there's a database on the back end, the best database environment might be a big Solaris box with Oracle running on it. So we need to find a solution that works across these different environments. So if we think about the servers, one of the things that as you move into a cloud environment you need to be able to do is to create an environment where the server almost protects itself. So if you think about multiple layering, which is what a lot of the analysts are talking about now, we can't rely on things to be out on the network. Because if it's in a multi-tenanted environment, that may move as you switch a VLAN around, or it may move because you've taken your service from one service provider to another service provider. So we want to create an environment where the VMs or the physical servers are almost self-contained. They're able to protect themselves and provide these different kinds of capabilities. So, a lot of people have firewalling out on the physical network, but if we're able to bring that into the physical server, then it can start creating rules that are specific to the workload that's running on that particular server. And the same is true of some of these other things. We want to perhaps check the integrity of the environment that's running. Have things gone in and modified the registry or modified memory? Have things, antivirus kind of taken as a standard these days? Virtual patching and HIPS protection seems to be an area that's gaining a lot of interest in many customers I'm talking to. So from a physical perspective, we want it to be self-defending. In the virtual world, a whole series of other challenges start to come into play. If you think about the environment that you're in, have you been very aggressive in virtualizing?
In some aspects.
Yeah. And the whole point of a cloud solution or a virtualized environment is that it's becoming more dynamic and more kind of self-provisioning. But by its very nature, that means that there's a lot more things to manage. So, some of the big banks that I've worked with, they've seen what used to be a certain amount of servers, so 10,000 servers, when you switch into a virtualized environment, suddenly doubles in size because it's so easy to create them and so easy to hang on to them.
I think that and the fact that with various things such as PCI and everything else, the PCI mandating the fact that effectively it's one server, one job.
Yeah.
Whereas in the physical world, it was far too easy to load a little piece of software
onto this server because, well, it's not doing anything anyway. It's only the domain controller, so it's fine. We'll just put this little thing on it.
This other thing on it.
Yeah, and so it ends up that the server's in, you know, multiple roles. Where in a virtual environment, as you say, it's far easier to spin another VM up, and therefore they've snowballed because, let's say, PCI mandates one server, one job.
Yeah. So, you know, when I used to deal with a lot of the early ASPs or service providers, what customers got was a blade or a pizza box. These days they're all virtual. So it's very easy in a relatively small data center to have 20, 30, 40,000 VMs that are all spinning up and spinning down, and you know, somebody has to manage that. And I don't think anybody at the moment has more resource than they had last year. You know, the amount of service that we're being expected to manage is growing exponentially. So, you know, some of these fairly obvious things about, you know, provisioning new VMs or patching them are challenges that people have.
That's really quite interesting. You see, the way you said it, I hadn't thought of it that way, because the whole idea of virtualization is to bring you a lot of simplification rather than do something with hardware, physical machines. It's so much easier because it's all online.
It's like kitchen cupboards, isn't it? The more you have, the more you'll fill.
Yeah. Yeah.
But the beauty of a virtualized environment is, unlike your kitchen cupboard, which is limited in size, this can take a lot more tin cans than the original cupboard could.
And then you can lose it all together.
Yeah.
But a cloud provider, it's in the interest of the cloud provider to make you use more megabytes of storage and more data throughput, because he can charge you more for it.
Yeah.
So the more he's motivated to make these things as easy as possible for you to do.
So for him, it's all about self-service provisioning. Make it very easy to pop one up, and as a value-added service to you, Mr. Customer, I'll keep a copy of that as well. So if you turn it off and you want to come back to it, you've still got this old one.
Now paying for 2.
So you're now paying for 2, or you're paying for 10 that are offline, plus the 5 that are online that you actually want to run your production workloads. But at the end of the day, what you've got is what people are now terming VM sprawl. And part of the challenge of VM sprawl is that, from a security perspective, you've just got a lot more things to manage.
It's a bit like having that server under the desk that you forget.
Yeah, because you'll have a VM that's in a VM lab that you forget, or 20 that you forget. The other challenge in a virtual world is they can come up and go offline. So the instant on gap is much more visible in a virtual world or in a cloud world, because they can change very, very quickly. So you can turn them off, reactivate them. And one of the challenges that happens when you do that is that the security is out of date. So if you haven't used that VM for a while, you haven't patched it for 3 months, you haven't updated the pattern files, you haven't updated the executables. Most of the software that we run today has auto-updating capability, or you've got tools that you use to go and patch and keep things up to date. If it's in a lab environment and it's not been touched for a while, and then it comes back online, it's either going to be a risk because you'll let it run unpatched and unchecked, or it will take a while to come back up to date.
So this concept of a lab with a cloud provider would be some servers that are entirely under your control and not maintained by the cloud service provider.
The only maintenance the cloud service provider would do is keep them available to you. So most of if you buy a server off Rackspace or Google, as well as having a production one, when you take that offline, it'll ask you, do you want me to keep it for 3 months or 6 months? So that if you want to, you can come back and restart it.
In the meantime, there's no patching.
In the meantime, nothing's happening. It's just been parked on storage somewhere.
Presumably, if you pay a bit more, then the service provider will bring it up to date, keep it up to date.
Yeah. But then there's complexity and manual intervention involved in that. So that's where the responsibility thing comes into play.
You're obviously seeing an amount of this. Anecdotally, I'd kind of say that the big issue is around patching, is around outsourcing, and then the issues that outsourcing come from a patching point of view, in that, you know, my contract says that you're going to give me an uptime of this, you'll provide me with N number of patches a year, and I'll allow you to go outside your SLA for those patches, but you've only got 5 days of that.
Yeah.
I hit 5 days within the first 2 months, at which point the systems never get patched again for the next 10 months, and so therefore that's the problem. A lot of the issues that we've seen, you know, as I kind of mentioned earlier, the simplicity of some of these attacks are badly written software, and the fact that people just don't apply patches. And I'm just wondering if you're seeing things different.
Or fixes aren't available. So,
but with the government side of things, all of, I can't remember what the percentage was at the last meeting, but there was a huge percentage, something like 90% of the attacks that were performed on government websites were all on known, patched, some of them 2 years old vulnerabilities, which is just, that then, you know, you could wipe out huge percentages of that just by doing what we should be doing properly now. We don't need to reinvent the wheel at that point.
Yeah, from some experience, again, no names, no patch drills, the HMG client will say, well, why aren't you patching these boxes? Well, you haven't paid for it.
Yeah, because or you're not letting me, by virtue of the fact that, you know, how the contract has been written to such an extent that you've
uptime,
got,
isn't it?
Yeah, and you've got a number of days. I'll let you off that uptime for these number of days, but you've exceeded those days before you even start.
Yeah,
And now you can't do anything.
99% uptime. When do you patch? You don't, do you?
So, I mean, there's a number of things that I normally end up talking about. One is kind of the different ends of the spectrum. So Microsoft, very aggressive. Every month, Patch Tuesday comes out. Here's a big wodge of stuff. And the wodge of stuff is made up of 2 bits. It's made up of the patches. So here's the answer. And by the way, here's all the vulnerabilities that we've identified. So the good guys go for the patches and start testing, and if they're good, start testing and work out what the impact's going to be. And it can be hours, days, months before they get round to saying, I'm going to apply it now.
Yeah.
The bad guys in the first 48 hours are going, yeah, hey, here's all the vulnerabilities. The other side of the spectrum is somebody like Oracle doesn't tell you about vulnerabilities. So Oracle, Linux, SAP, the only reason you find out that there's a vulnerability is if you hit the problem and you go looking for the fix. So you've got the 2 ends of the spectrum, one where they're trying to be good and tell you about this ahead of time. So recently there was an RDP vulnerability, and it took 2 months before Microsoft came out with a fix for it, but they let people know that it existed. And, you know, Oracle's had a vulnerability on Oracle now for probably nigh on 18 months that hasn't got a high enough priority to actually get fixed. So, you know, you've got the 2 ends of the spectrum there. The other thing that we see is it's very easy in a virtualized environment and a cloud environment to just clone things. And if it's already out of date because it hasn't been used for a while, and then you start cloning it, then, you know, you're exacerbating the problem. So, you know, the challenge is not only out-of-date security, but out-of-date operating system and applications as well. The other thing with cloud and virtual is it's supposed to be dynamic. So the ability to move a machine from one physical server out to another, or out to another environment, should be simple. But because of some of the restrictions, either with the network, so VLANs, you know, if you've created VLANs for specific clients as part of your cloud network, and you try and flip a machine from one VLAN to another, then you have to go and change the network rules. If it's protected by a single firewall layer that's in the network, and that might be specific to one data center, but you're moving to another data center, then you have to go and change the firewall rules. So we've seen a lot of instances where vMotion and all of those kind of dynamic tools are very attractive because they offer value. You can save power, you can load balance and all those kind of things. Sometimes the security is inhibiting it because you have to go and make manual changes in a number of other areas. And so people just don't have a dynamic environment. And then the one that's probably most common is the updates. So if you do have security built into all of your VMs, then 9 o'clock in the morning you may do a pattern file update or a signature file update. 3 o'clock in the morning you might do an integrity scan. But the net result is that often it causes meltdown on the back end, because it creates a big burden onto either the SAN or onto the server, particularly as people start moving to virtual desktops. The thing that sets virtual desktops apart from virtual servers is the density. You're talking about hundreds of servers instead of dozens. Or
so by this storm, you effectively referring to the fact that I've now got 100 virtual desktops in my virtual environment, and now I've got 100 machines all going and doing the same thing at the same time.
So I was working with a college up in the northeast. They did a pilot on VDI for making flexible working for students. So you can come in with BYOD and activate iPads and things. The pilot was great because it was 50 users. They were told by their hardware vendor that that particular server could support 100 users. So they built a business case that says, right, we're going to roll this out for 400 students. And what they had was their existing SAN on the back end. When they moved from the 50 pilot into the 200 as they started doing the initial rollout, it just caused a meltdown on the back end. Because trying to update those 200 pattern files, because they were using persistent desktops, it just caused an I/O bottleneck on the back end. So they were in a position where they were going to have to go back to the finance board and say, by the way, can we have a shiny new SAN with SSDs?
Is it not just a question of scheduling? I mean, something on a very different scale. Download Tuesdays. Microsoft does that kind of thing, but it's just a matter of organising an agreeable, workable schedule. It's not really a big deal.
So the answer is yes, if you do it.
Oh.
So what most, in the server world, what most people have done to date is a P2V. They use a simple tool that says, right, I'm going to take an image of my physical, drop it into my virtual. When they did the physical, that server was only 15% utilised, so it had a ton of memory, a ton of CPU available to do the scanning and things. When they take all of those images and put them into the virtual world, they don't go and change the schedule of when the scan happens. So it causes a problem. If you take a non-persistent environment, so most VDI implementations are non-persistent desktops where they dynamically build them. If they build security into that image, again, it will have a common time when the scan's going to So you're building it off a gold image and you cookie cutter 100, they all have the same configuration filing. The other thing that we've seen is you randomize it. And if you randomize the scan, it will work for the most of the time. As soon as it hits that point where randomly they all kick off at the same time, nobody knows why it's happened. Whereas if it happens regularly, you know it's happening because the scan takes place. So, there's quite a few challenges. VMware, unlike Microsoft and Citrix, have done something about it. So they've created the suite of tools called vShield and started to build in security into the hypervisor. So Microsoft now have the edge components that allow us to create virtual data centers, so you can build layers of kind of network protection around virtual machines. You've got the same sort of thing on the application side, and then they've worked with vendors like ourselves to build security into the endpoint solution. So instead of running security in each of the individual VMs, we can now bring it into the hypervisor. And from a cloud perspective, that has a number of benefits. One of the most significant ones, and I was with a cloud provider this morning, the reason they brought security down into the hypervisor is for consistency. Because if they were selling VMs to different customers, and those different customers put different security solutions in, they have no idea when a spike is going to happen in a particular VM. Because they don't know what tools the customers put into the VMs. So from their perspective, if they're providing that security service down in the hypervisor, then they've got greater control over the risk and greater control over the SLA that they're going to be delivering. So from their perspective, it kind of makes sense. The other thing that VMware has done is enabled all those different controls to be delivered. So, where we were talking about self-defense, you can apply that to a VM now as well. So from an agentless perspective, you can deliver all of these different security controls, which are the common ones that you want to do to protect the VM or to protect a workload, but now deliver these within the hypervisor. The only exception is that currently log inspection has to take place with an agent. So if we think about that from the life cycle of a VM, the different controls take place at different times. So if we're doing dynamic provisioning, so most self-provisioning environments within a cloud provider, they're going to get built off a gold image. So we want to be able to check the integrity of that gold image. If we're dynamically injecting applications, we want to check the thin app or the app V and make sure that the application is still sound. Because we're going to provide a good service and we want that machine to work first time. What we also want to do is to make sure that the firewall and the antivirus are up to date. So if that's delivered as a service within the hypervisor, it's much more efficient and much more performant. And the same is true of all these other environments where we're thinking about moving or restarting VMs that are out of date. So one of the things that you can do in this approach is that you can create virtual patching. So what we've done and what a number of other vendors have done is come up with an environment where instead of applying a physical patch, on Patch Tuesday, taking all the information from Microsoft and applying them and testing them, what we've done is created virtual patches. So we take the vulnerability and come up with a network-based solution that allows us to achieve the same thing. So if you think about some of the comments earlier on about applying the patches, with virtual patching, because it's at the network layer, we can do it straight away. So on Patch Tuesday, you've got an SLA that says, I've got the equivalent of those patches that are now being applied at the network layer. You can then take your time to test the patches and make sure that there isn't impacts, either because they don't work with that particular environment or they don't work with variations of that environment, which is often where the challenges happen. The other thing that we're seeing is that the cloud providers, because they're on a very aggressive uptime requirement, they have scheduled maintenance slots. So they might only have a maintenance slot once a quarter where they're allowed to take the machine down or to apply physical patches. The other thing that we've seen this year is the Olympics freeze. Public sector is locked down for this period of time because they daren't change anything in case it breaks. Atos have been in lockdown probably since Easter. And they're not applying any patches to any of the systems that support the Olympics. The other thing that we want to do in that kind of self-defending environment is to pick up threats in different layers. We want to potentially stop threats getting onto a machine, so that exposure layer, working with the reference database, we want to be able to identify things that are trying to attack a VM or trying to attack a physical server and stop them getting onto the machine. Antivirus is this kind of bit in the middle. The assumption with antivirus is that the threat's already on the machine. And if it's already on the machine, it's already had an opportunity to attack it. So for antivirus to be effective, it's got to be known and it's got to be present already, which is kind of too late. because it's already there, and in order for you to find it, it needs to be a known threat. Then the final piece is that kind of behavioural stuff that we spoke about earlier on. We need to identify unusual activity and be able to react to it. So if a PDF file that is an attachment suddenly starts opening up an internet connection or broadcasting externally, that's probably not normal behaviour for a PDF. But it might be normal behaviour for a Microsoft form, a Word form or something, where it's connecting to a server to fill in fields in a dynamic form. So there are different behaviours and things that you want to pick up. The other thing with the cloud environment is that we've got kind of two options and two ways of doing it. We can either have the responsibility retained with the client. So if I'm a client and I'm buying a service from a cloud provider, I may want to retain control of the security. So I can, in those VMs that I'm buying from the cloud provider, install my security service, but it's self-contained. So I can continue to manage it and I continue to manage my security, but it's remote. Or I can flip that over and let my cloud provider deliver that kind of security. So we're able to provide the reassurance either to the client or to enable the service provider to provide that reassurance. And it's kind of down to the different kinds of services that the service providers want to offer.
Coming back to your Amazon user level agreement, what guarantees do you give if you're going to do the security?
So, us as a vendor, or?
Yes, when you say that in that case, instead of the client doing the security, you're going to do it for them.
Well, in this example, it would be the service provider. So some of the service providers I'm working with have taken our technology and other people's technology, applied policy to it. So, CESG will look at the architectures and determine that they've taken all sensible measures.
But is the end user agreement the same as the Amazon end user agreement? Whose liability is it?
So the end user agreement then is a contract between the service provider and the individual client. So, I'm working with a service provider at the moment that is offering IL3 multi-tenanted G-Cloud services. So their contract is underwritten by CESG and kind of audited by CESG, and the contract is very specific about where responsibility lies for security. And in their case, they're taking it into their environment and they're saying they're going to provide security at the hypervisor layer.
Who's they? Who are they?
The service provider.
So
the EULA is very different, or instead of being a EULA, it becomes a contract.
What's interesting, last week or last couple of weeks ago, Google announced that for their product Google Apps, they actually have now attained to 27001 accreditation. So anybody using Google Apps would have that similar tick box, but now they're supposed to be assured by the fact that Google has 27,001 certification.
That's the scope.
It's interesting to see that actually I went on to Bureau Veritas to see if I could see the certificate, to see just that, the answer to that question, but I couldn't see it.
No, neither did I.
But it did say it was just limited to Google Apps.
My favourite story about that was that the bank which said their internet banking service was 27,001. When you looked at the scope, it was just the log on screen.
Exactly.
So to come back to a point we were making earlier on about kind of security enabling it, in this example with VDI, if we bring security out of the individual VMs and put it into the hypervisor, you can actually almost triple the density of virtual desktops that you get onto a particular server. So we've seen in a number of our clients where by taking security out of the VM and putting it into the hypervisor, the performance of the application actually improves. So we were talking earlier on about XenApp, terminal services. Often a XenApp or a terminal services environment, you're restricted on the number of users you can get onto it because of the memory. If you free up a ton of memory that's normally occupied by security, then you can get more users on. So we've actually seen security being an enabler to the business case and to delivering flexibility. One of the things that we mentioned earlier on is the idea of, instead of thinking about the network and coming in, we need to make the data our core tenant for security, and think about protecting that asset and then layering security out from there. So in that environment, these kind of things become very important when we're considering what's going to get access to that data. We need to be looking at when you're allowed access to it, who's been accessing it, where was it accessed from? Has somebody accidentally cloned this volume from Europe to North America? In which case, it comes under different rules and regulations. The other thing that people often forget is, with a cloud provider, the whole idea is that it is a flexible environment where you can move. So if you've got a ton of data there that you move into the cloud, but then you move your service, what happens to that data? Sorry, the animation didn't work. There it is. So we had a Chief Security Officer stand up at this customer event a couple of weeks ago, and he talked about buying VMs off a number of cloud providers. And then he went and looked at the volumes he was given to see if there was any data left on there. And he was amazed. In 90% of the cases, there was still data that was accessible on those volumes. So as a cloud provider, it's not only about the service you deliver, but it's also about the service that you have to offer to clear up after that organisation has left. So data destruction is almost as important as data access. Because if you bought a service off somebody and then you switch out, that data is vulnerable if it's left there and it's not properly destroyed. The MOD, when they talk about that, they want the shattered platters back. Very impractical for a cloud provider. Yeah. So we've kind of spoken about protecting the servers and the kinds of things that we can do in that environment. As far as data is concerned, encryption is what a lot of people are going to be looking at. So we've got to find a way of providing an encryption technology that can secure the data in the environment that the cloud providers are offering. So we've worked with a number of vendors here, and what we've come up with is a construct where we can encrypt the data volumes or the logical data volumes that are associated with the VMs that are running. So you can see here that we've got specific keys that are associated with those individual VMs, and that way we can guarantee that the data is only accessible when you want it to be accessible. So under an audited policy, and when the data is at rest, that you've got the reassurance that it's encrypted while at rest in that cloud provider's environment. The value of the encryption is that when you move that service, you take away the keys, and therefore you've got the equivalent of data destruction. So when that, if you take your service away and move it to a different provider, any remnants of data are effectively lost because you take the keys with you. Try and put that in context, and again, this is one of the areas where we can spin it back the other way and talk about how security can be an enabler. So in this example, we've got a number of customers that are using virtual machines. We've encrypted the data, so you've got the reassurance that that data is not accessible by staff within the cloud provider, but can only be accessed by the application that's specifically designed to access that data. You've got a policy server that says, what are the rules before I allow access to that data? So there was a fairly famous compromise with a marketing company that had data from multiple organisations, including Marriott and M&S and people. And what they had was a suite of applications that processed that data at different times. But the data was open and accessible. So because they didn't have an ability to apply policy that said only release this customer's data at a particular point in time, they got compromised and all of that data was available. So with this environment where we can encrypt the data, You've got the reassurance here, the kind of auditability. You've got the policy that you can apply to it to determine who, when, why, and where it was accessed. But that information can then be given back to the client along with the keys. So if this is being provided by a cloud provider, but the client retains the keys to open up the access to the data, then again they've got responsibility themselves for whether that data is accessible or not. The other thing that this offers is that potentially you can start using shared services. So a lot of the early kind of cloud providers had dedicated hardware for different clients. If you move to a virtual environment and you've got a SAN infrastructure, this test volume over here can be in a shared service model. So you can drive down the cost of providing that test environment or the user acceptance environment.
Who generates the keys?
The keys are, so we have the key management capability, and there's a number of other vendors starting to get into it. So the keys are either generated by us as a service, so we can provide it as a software as a service model. They can be held by the cloud provider. So we're talking to one of the organisations around the table here.
But that doesn't prevent insider attacks if you're generating the keys and have access to it.
If we're providing the keys and they're providing the infrastructure and the client's driving the policy, then the client can determine what policy is applied and when keys are released or not released.
Yes, but you have the keys in your organisation, don't you? You're generating the keys.
Yes.
So an insider attack could be a threat.
Potentially, yes.
Yes. The only security is if the customer generates the keys and controls the keys.
So the key server is available for the customer, for the service provider, or for us as a service. So the client can determine where they want that control to be.
Yeah, I mean, the secure design is the customer generates the keys and controls access to the keys. That's a safe bet. If you rely on anybody else on it, then you're exposed. Or you don't know that you're being compromised.
Yeah. But the encryption seems to be the way that a lot of people are looking at protecting the data that goes out into cloud environments now.
Yeah, it's the only way.
So, the bottom line is that, in order for cloud providers to operate, we need something that works physical, virtual and cloud. We want to be able to provide multiple controls so we can be self-defending rather than rely on a particularly strong network environment. And, as we kind of highlighted earlier on, you need the external verification as well. So we're working with the common criteria people, FIPS and CESG. So, if you think back to the policy piece, it's not only the policy that you create, but it's the validation from the external people as well. So in the government environment, code of connection and those kind of things.
Where is this developed? Your headquarters in China, aren't you?
Our headquarters are in Japan, but it's developed around the world.
Right.
So we have a split brain. We're listed on the Japanese Nikkei, and we have our corporate headquarters in North America. But then we develop different technologies in different parts of the world. So the FIP stuff is all developed in North America and under control of the US regulations and things.
Steve, we have, if we'll stick to the planned finish time, 1:30. We've got just over 10 minutes. We've got about 5 minutes. If you
The only thing that was there was what a great job we've done with VMware. So this is a marketing plug. We've been working with VMware since 2008 to build those controls into the hypervisor. We are talking to Microsoft and Citrix, but they're not quite as enlightened or as pervasive as VMware at the moment. So you can achieve the same thing. A number of partners now are looking at Hyper-V as the virtualization platform because it's free. But you pay for it elsewhere.
Are you aware of what Dell are doing in this field, in this general field, with Secure Works and
So they're one of the partners that we work with. They take some of our technologies.
Right, so they're using your technology.
And that encryption technology is one of the key ones that they're working with us on. So that was it.
Well,
hopefully there was a couple of vaguely interesting pieces within that.
Absolutely.
With all the interaction,